Hello, my dear students. Today we are going to continue chapter 1. We are going to continue our discussion on the general properties of first transition series. We are going to discuss the magnetic property and the colored ions and the catalytic activity. So let us start. General properties of first transition series. The magnetic property. They are attracted to an external magnetic field, and we have given reason for this point. This is due to the presence of unpaired electrons in the 3D orbitals, such that the magnetic field resulted from their spin motion is attracted to the external magnetic field. My dear student, the magnetic moment is the number of unpaired electrons in the d sublevel. The magnetic moment increases till we reach manganese of atomic number 25, as its d sublevel has 5 electrons, and according to Hund's rule, so we have 5 unpaired electrons. Then decreases till become 0 at zinc of atomic number 30, as has no unpaired electrons. My dear student, the magnetic moment determines the electronic configuration of their ions, and we have given reason for this point. The reason is it indicates the number of unpaired electrons in the d sublevel. My dear student, we are going to discuss the types of the magnetic properties. First property is paramagnetic property or paramagnetic substances. The paramagnetic property appear in the ions or atoms or molecules in which their orbitals having unpaired electrons, and their magnetic moment depends on the number of unpaired electrons, which lead to the attraction to an external magnetic field. The paramagnetic substance can be defined as it is the substance that attracted to an external magnetic field due to the presence of unpaired electrons in the d sublevel. The diamagnetic property for transition elements, my dear student, it appears in the substance which all the electrons in the orbitals are in paired state, and the magnetic moment is 0, such they repelled out in an external magnetic field, and the paired electrons spin in opposite direction, so no detecting magnetic property. So we can define the diamagnetic substance, my dear student, it is the substance that repelled out in an external magnetic field as the electrons in all orbitals are in paired state. My dear student, notice that most of compounds of transition elements are paramagnetic, as having unpaired electrons in the d sublevel. So we have given reason for this point. Zinc chloride is diamagnetic, but manganese 2 chloride is paramagnetic. The reason for that is zinc that has atomic number 30 has electronic configuration argon 18 for S2 3d10. When zinc chloride is forming, it means zinc positive 2 ion is formed, has electronic configuration argon 18 3d10 after losing the 4s electrons. So the d sublevel, its orbitals, all electrons are in paired state, so has completely filled d sublevel. While in manganese of atomic number 25 has electronic configuration argon 18 for S2 3d5, and so in manganese 2 chloride, manganese positive 2 has electronic configuration argon 18 3d5, and so we have 5 unpaired electrons in the d sublevel. Another give reason for this point, iron 3 compounds have higher magnetic property than iron 2 compounds. The reason for that, when writing the electronic configuration of iron positive 2, it will be argon 18 3d6, As shown on the screen, the 3d orbitals contain 4 unpaired electrons in the d sublevel, so have lower magnetic moment than iron positive 3, which has electronic configuration argon 18 3d5, and so we have 5 unpaired electrons in the d sublevel. My dear student, we are going to study worked examples. Which of the following substance is paramagnetic and which is diamagnetic? Zinc has d10 electrons, copper 2 ion has d9 electrons, iron 2 ion has d6 electrons. Write the order of their magnetic moment. If you answer this question, my dear student, you write the electronic configuration and number of unpaired electrons and its magnetic property. Zinc has d10 electrons, number of unpaired electrons 0, it is diamagnetic. Copper positive 2 has 9 electrons in the d sublevel, so has 1 unpaired electron, so it is paramagnetic. And iron positive 2 has d6 electrons, so the number of unpaired electrons is 4, so it is paramagnetic. Next example, study the magnetic properties of the following transition salts. Iron 3 sulfate, Fe2SO4O3, and titanium 4 chloride. The answer, my dear student, you have to write the iron positive 3 ion electronic configuration after removing 4s2 and 1 from the 3d6, so it will be 3d5, as it has atomic number 26 and its electronic configuration argon 18 for s2 3d6. So losing the 3 electrons to be iron positive 3, so the 3d sublevel has 5 electrons. As shown on the screen, these are 5 unpaired electrons, so it is paramagnetic and the magnetic moment equal 5. In titanium chloride, titanium 4 chloride, titanium has positive 4 oxidation state. As we know, titanium atomic number is 22, so the electronic configuration argon 18 for s2 3d2. So losing 4 electrons to be titanium positive, losing the 4 electrons of 4s3, so the 3d will be empty, and that means it is diamagnetic and the magnetic moment equal 0. Next example, study the magnetic property of the cations of the following transition salts, then arrange them in ascending order according to their magnetic moment. Iron 3 chloride, chromium 3 oxide, titanium 2 oxide. Here, my dear student, iron 3 chloride, if you write the electronic configuration of iron positive 3, it will be 3d5. It means have 5 unpaired electrons, so it is paramagnetic and the magnetic moment equal 5. And in chromium 3 oxide, the chromium positive 3, we know, my dear students, that chromium has atomic number 24. So when writing the electronic configuration of chromium, which is abnormal, argon 18 for S1 3d5, and so by losing the 3 electrons, so it will be argon 18 for S0 3d3, and so it has 3 unpaired electrons. So it is also paramagnetic substance and its magnetic moment equal 3. Here the next one is titanium 2 oxide. Here the titanium has positive 4 oxidation number. And we know that the titanium has atomic number 22, argon 18 for S2 3d2. By losing the 4 electrons to be titanium positive 4, it will be 3d0. So no unpaired electron here, so it is diamagnetic and magnetic moment equal 0. So the arrangement here according to their ascending order of magnetic moment, titanium 2 oxide, then chromium 3 oxide, then iron 3 chloride. The next property we are going to discuss today is colored ions. Most of compounds of transition elements and their solution, that we call hydrated ions, are colored. The explanation of the color of the transition elements. My dear student, when white light, which is 7 colors, fall on the transition element, what happens? the unpaired 3D electrons absorb some photons of visible light, and so they raising the 3D electrons to higher levels, while the other colors are reflected, giving the eye the apparent color of the element. My dear student, notice that the absorbed color is known as supplementary color, and the reflected color, which is the apparent color for the eye, is known as complementary color. So, my dear student, the following table shows that the number of unpaired electrons in the ion, and so it is colored or not. So, here scandium positive 3 outer configuration of the 3D sublevel is empty, so no unpaired electron, so it is colorless. Titanium positive 3 has 3D 1, so number of unpaired electron 1, so it is colored and has red violet color. Vanadium positive 3 has 3D 2, 2 unpaired electrons, so number of unpaired electron is 2, so it is colored and has blue color. Chromium positive 3 has outer electron configuration of 3D sublevel 3D3, so has 3 unpaired electrons, so it is colored and has green color. Manganese positive 3, the outer electron configuration of it has 3D4, so it has 4 unpaired electrons, so it is colored and has violet color. Manganese positive 2, the outer electron configuration of its ion is 3D5, so it has 5 unpaired electrons, so it is colored and has red or pink color. My dear student, to know the color of the elements, we have to know the supplementary color and the complementary color. If the supplementary color is violet, so the complementary color is yellow. And if the supplementary color is blue, so the complementary color is orange. And if the supplementary color is green, so the complementary color is red. If the supplementary color is yellow, so the complementary color is violet. And if the supplementary color is red-purple, so the complementary color is green. You have to keep these colors, my dear student. Here we have given reason for this point, my dear student. Chromium 3 compounds appear green. The reason for that is they absorb the red light to raise the 3D electron to higher level, while the other colors are reflected, so appear green. My dear student, notice that the absorbed color, which is called supplementary color, plus the reflected color, which is complementary color, equal white light. My dear student, the colorless compound occur when the d sublevel is completely filled by electrons, as zinc positive 2 and copper positive 1, and if the d sublevel is empty, as scandium positive 3. So we have given reason for this point. Copper positive 1 ion is colorless, but copper positive 2 ion is colored. The reason for this point is that the copper positive 1 has electronic configuration argon 18 3d10. As we know, my dear student, the copper has atomic number 29, which is abnormal configuration, copper argon 18 for S1 3d10. So copper positive 1, by losing the 1 electron from 4s sublevel, so as shown on the screen, the electronic configuration of copper positive 1 argon 18 3d10. So the d sublevel has completely filled electrons, so no unpaired electron here, so all the electrons are paired, so we can say it is colorless. While here copper positive 2, by losing 1 electron from the 3d sublevel, so has electronic configuration argon 18 3d9, as shown on the screen, has 1 unpaired electron, so it is colored, and the copper positive 1 is not colored. My dear student, we are going to discuss the catalytic activity for the first transition series. What is the role of the catalyst? The electrons in the 4s and the 3d orbitals form weak bond with the reactant molecules that increase the concentration of the reactants at the surface of the catalyst, so weaken the bond in the reactant molecules, so therefore decreasing the activation energy of the reactant, so increases the rate of reaction. My dear student, For example, for the catalyst is the effect of the manganese dioxide in the decomposition of hydrogen peroxide H2O2. As shown in the screen, the reactants give product in exothermic reaction, as the heat content of the reactant is higher than the heat content of the products. This reaction happens in the activation energy without catalyst, which is larger amount, and when adding catalyst, the activation energy has decreased, which in red line. So the effect of catalyst appears that decreases the activation energy of the reactant, so the reactions happens by lower temperature. Example for this reaction or this catalytic activity: the divided nickel in hydrogenation of oil, the divided iron in ammonia formation. In the ammonia formation, that we call Haber-Bosch process, we know that the nitrogen gas reacts with hydrogen gas in the presence of catalyst, iron or molybdenum, at 500 degrees Celsius, and at 600 atmospheric pressure, it gives ammonia gas. Another example for the catalyst is vanadium pentoxide, V2O5, which is used in the preparation of sulfuric acid in industry that we call contact method. Here, sulfur plus oxygen by heat gives sulfur dioxide gas. Then sulfur dioxide gas is oxidized by oxygen, giving sulfur trioxide gas in the presence of vanadium pentoxide as catalyst and for 450 degrees Celsius. Then sulfur trioxide gas dissolves in water, forming sulfuric acid, as shown on the screen. Now we are going to talk about example of catalytic activity. In the following diagram, as shown on the screen, the reactants take 130 kilojoule per mole to give the unstable step, then give product releasing 210 kilojoule. And by using catalyst, here the energy is 180 kilojoule per mole. So find the following: the activation energy without catalyst. As shown on the screen, here the activation energy without catalyst is 130 kilojoule per mole. And the activation energy with catalyst, as shown on the screen, here it is 100 kilojoule per mole. And the type of the heat exchange of the reaction is exothermic reaction, as the heat content of reactant is higher than the heat content of product. And the value of the heat exchange of the reaction, which is the difference between the heat content of reactant and the product, so it is 80 kilojoule per mole. Now, my dear students, we are going to discuss some questions on this episode. Choose the correct answer. Zinc 2 ion is characterized by its diamagnetic property due to what? Presence of 3d paired electrons. 3d sublevel is filled by 8 electrons. 3d sublevel is filled by 5 electrons. The presence of 4 unpaired electrons in 4s sublevel. If you think about it, my dear student, you will find the answer is the presence of 3d paired electrons. Next point. All the following ions are paramagnetic except what? Vanadium positive 2, chromium positive 2, zinc positive 2, iron positive 2. If you think about it, my dear student, by writing the electronic configuration of each element and then writing the electronic configuration of its ion, and you will find that the only one which has unpaired electrons, here it is paramagnetic. So all of these elements are paramagnetic except zinc positive 2 that has no unpaired electron. So it is diamagnetic. Next point, zinc ion 2 is colorless due to what? Presence of 3d paired electrons. 3d sublevel is filled by 1 electron. 3d sublevel is filled by 8 electrons. The presence of unpaired electrons in 4s sublevel. If you think about it, my dear student, you will find the answer is the presence of 3d paired electrons. Next point. All the following ions are colored except what? Vanadium positive 2, copper positive 2, copper positive 1, iron positive 2. My dear student, if you think about it, you have to know that the presence of unpaired electron gives the color of the compound. No unpaired electron, it will be colorless. So all the following ions are colored having unpaired electron except one which has no unpaired electron, which is copper positive 1. Next point. Iron 2 ion is characterized by its paramagnetic property due to what? Presence of 3d unpaired electrons, 3d sublevel is filled by 10 electrons, 3d sublevel is empty, the presence of unpaired electrons in 4s sublevel. If you think about it, my dear student, you will find the answer is the presence of 3d unpaired electrons. Next point. The atomic number of a metal, its magnetic moment equal to, what is it? Is it 23 or 29, 21 or 22 by 28 or 27? My dear student, the magnetic moment to be 2, so it must be 2 unpaired electrons in the d sublevel. So the atomic number to have 2 unpaired electrons, it must be 22 or 28. Next point. Iron 2 ion is colored due to what? Presence of 3d unpaired electrons, 3d sublevel is filled by 10 electrons, 3d sublevel is empty, the presence of unpaired electrons in the 4s sublevel. If you think about it, here's the answer. It will be the presence of 3d unpaired electrons. Next point. Magnetic moment for the paramagnetic substance increases by increasing of what? Atomic number, mass number, number of single electrons, and number of paired electrons. If you think about it, yes, it will be number of single electrons, which you call the unpaired electrons. Next point. Copper 1 ion is colored due to what? The presence of 3d paired electrons, 3d sublevel is filled by 1 electron, 3d sublevel is filled by 8 electrons, the presence of unpaired electrons in 4s sublevel. If you think about it, yes, it will be the presence of 3d paired electrons. Next point. Copper 1 ion is characterized by its diamagnetic property due to what? Presence of 3d paired electrons, 3d sublevel is filled by 8 electrons, 3d sublevel is filled by 5 electrons, the presence of unpaired electrons in 4s sublevel. If you think about it, yes, it will be the presence of 3d paired electrons. Next point. Copper 2 ion is characterized by its paramagnetic property due to what? Presence of 3d unpaired electrons, 3d sublevel is filled by 10 electrons, 3d sublevel is empty, or the presence of unpaired electrons in 4s sublevel. If you think about it, my dear student, it will be the presence of 3d unpaired electrons. Next point. Copper 2 ion is colored due to what? The presence of 3d unpaired electrons, 3d sublevel is filled by 10 electrons, 3d sublevel is empty, the presence of unpaired electrons in the 4s sublevel. If you think about it, yes, the answer, it will be the presence of 3d unpaired electrons. Next type of question. Write the scientific term of substances which we are repelled out in the external magnetic field because all their electrons are paired. If you think about it, yes, it will be diamagnetic substance. Next point. The number of unpaired electrons in the d sublevel. If you think about it, yes, it will be magnetic moment. Next point. A substance that is attracted to an external magnetic field due to the presence of unpaired electron. If you think about it, yes, it will be paramagnetic substance. Next point. The absorbed color from the visible spectrum by transition element. If you think about it, yes, it will be supplementary color. Next point. The reflected color from the visible spectrum by transition element. If you think about it, yes, it will be complementary color. Next point. Elements that have partially filled D or F sublevel In their free state or ionic state, if you think about it, yes, it will be transition element. Next type of question, give reason for. The atomic radius of the first transition series is nearly constant from chromium to copper. The reason for that, the presence of two factors which are opposite to each other, which are increasing the positive nuclear charge that increases the attraction force of the electron and increases the number of unpaired electrons at 3D sublevel, which increases the repulsion force between the electrons. Next point. Elements of the first transition series are used in making alloys. The reason for that is the reason that the atomic radius is nearly constant. Next point. The first transition series have high melting and boiling point. The reason for that, due to the presence of strong interatomic bonding that we call metallic bond that involves the electrons of 4s and 3d in the electron cloud. Next point. The density of the first transition series increases with increasing of atomic number. The reason for that, because the atomic mass increases with increasing of atomic number while their atomic radius is nearly constant, as density equal mass over volume, which is high mass over constant volume. Next point. The first transition series have variable chemical reactivity. Because copper has low reactivity, while iron has medium reactivity that rusts when exposed to air, and scandium has high reactivity. Next point. The first transition series are attracted to external magnetic field. The reason for that, due to the presence of unpaired electrons in the 3D orbitals, such that the magnetic field of the resulted electrons from their spin motion is attracted to the external magnetic field. Next point. The magnetic moment of the first transition series determines the electronic configuration of their ion. The reason for that, because the measurement of their magnetic moment indicates the number of unpaired electrons in their d sublevel. Next point. Zinc chloride is diamagnetic, but manganese 2 chloride is paramagnetic. The reason for that, because zinc positive 2 has electronic configuration argon 18 3d10, so all electrons are paired in the completely filled d sublevel. My dear students, we have reached to the end of our episode today. I hope you understood all the points and the questions that we discussed today. So till we meet again, my best wishes for you.